So let's see, 12.5. So we're going to talk about circles with coordinates. Now, we've talked a couple of times about the definition of a circle. We said the circle was all points that are the same distance from a center. And our distance, we decided, and we said the same thing for a sphere in 3 dimensions. The distance is the radius. So we can use the distance formula to write the equation of a circle. And the equation is going to describe where the circle is and what its radius is. So the equation that we're going to write down comes from using the distance formula. So we say that the distance of all of our points on the circle equal the radius. So what I want us all to see or realize is that when we write our equation of a circle, the equation really is the distance formula. So our equation of a circle So we're going to say our center is at the point is at HK. And I don't know why in math, when we're talking about circles, when you talk about parabolas, when you talk about other shapes, ellipses, hyperbolas, we talk about the center being HK. That's just the choice that mathematicians made for some reason. And the radius equals R. Our equation is x minus h squared plus y minus k squared equals r squared. Now, if we took the square root of both sides, we would have the square root of this thing, square root of x minus h squared plus y minus k squared equals r. R is the distance, and that square root, x minus x1 squared plus y minus y1 squared, that's the distance of that point the xy, the distance from xy to the center. So this is exactly the distance formula. And what we're talking about here, I'll just draw a little picture. We have some point on the circle. That point is at x, y. And the radius of the circle is r. And the center of the circle is at the point h, k. So nice, easy equation. I just want to do a couple of example problems using that equation. Really, that's the big idea for today. This is the equation of a circle. Are we good there? Okay. So let's say we want the equation of a circle with center -6, 8 and radius 5. When we have a problem like this is h and this is k, and we just plug that into our equation of a circle. So our equation is x minus negative 6 squared. That's x minus h plus y minus 8. That's y minus k equals 25. And that is 5 squared. And this should be x minus h squared, y minus k. I forgot my squared here. Squared. And I could simplify that. If you left it written like this, that would be fine. But I could write x plus 6 squared plus y minus 8 squared equals 25. That's the way you would normally see it. So just a little kind of way to think about this. If this is negative, it turns positive. If it's positive, it turns negative in our equation. So they're opposite signs. And that's all we have to do there. Questions there? All right, let's go the other way. If we have this, we want to find the center and the radius. Of the circle given by x minus 3 squared plus y plus 2 squared equals 36. Well, this is x minus h squared, and this is y minus k squared. So my center is going to be 3, negative 2. They change signs here. And the radius square root of 36, because this is r squared, 6. So between the point and the equation, these change signs. This is the radius squared, so we take the square root. All right, questions? All right, let's look at one slightly different example, and then we'll be done. We want the equation of the circle with a center at 4, 2 that goes through 2, negative 3. So what we're saying here, we don't necessarily have to draw a picture, but just so we can visualize this. We have a circle. We know that this is at 4, 2, and we know that this point is at 2, negative 3. So this point that's on the circle is at 2, negative 3. Well, we know the center, this center gives us h and k for our equation. What else, what do we need to know? What do we need to figure out? What's the missing piece in our equation? We need h, k, and r. We need the radius. Well, how do we find the radius? So we need to find the radius. We have those 2 points. How do we figure out the radius of the circle? Isn't the radius the distance between those points? Since that point is on the circle? So the radius equals the distance between the points. So we use a distance formula. Or we could plug into our equation, because our equation for a circle is the distance formula. So we can say x minus 4 squared plus y minus 2 squared equals r squared. Well, this point is an x and a y. That's a point on my circle. So I can say 2 minus 4 squared plus negative 3 minus 2 squared equals r squared. And this is exactly what I do if I plug these points into the distance formula. x2 minus x1 squared plus y2 minus y1 squared, and we take the square root of that. That's what we're going to do. Well, 2 minus 4 is negative 2 squared, plus negative 3 minus 2 is negative 5 squared. And it's important to remember, when we square a negative number, we always get a positive number. We should never have negative numbers in our distance formula once we square everything. So we get 4 plus 25 equals r squared. So r squared equals 29. We don't need to figure out the radius. We just want the equation of the circle. So my equation is x minus 4 squared plus y minus 2 squared equals r squared, 29. And that's my equation of the circle. All right, questions? Okay. If you're given a circle on a graph, you can count squares to figure these things out. You can count squares to figure out the radius. You can count squares to find points. So if you have a circle on a graph, don't worry about that. Don't let that throw you. All right, I need to show you one construction that you'll need for tomorrow. So let's do that really quickly. So this one, for this construction, what I need to do, I have a segment. And I want to divide it into equal pieces. Now, if it's an even number of equal pieces, it's easy. So, for example, if I wanted to divide this into 4 segments, how could I do it? Couldn't I divide it in half and then divide it in half again? So dividing it into even number of segments is easy. We can divide it in half and then divide the other one in half. So we know how to bisect a segment, find the perpendicular bisector, find the midpoint. We know that construction. But let's say we want to divide this into 3 equal segments. So when we're going to do our construction, we don't want to guesstimate, well, this is about 1/3. We want to construct exactly 3 equal pieces. So what I'm going to do is draw an angle. So I'm going to put this on here. Any angle, doesn't matter. So I'm going to draw that angle. Now I'm going to divide that into 3 pieces. And it doesn't matter how big they are. So I'm going to take my compass, then green, and I'm just going to mark out 3 equal pieces. So I can just do 1 and then move the compass there. 2, move the compass there. 3. So now each of these is the same length. And it doesn't matter how big they are. I just mark 3 equal pieces on that angle. Now I'm going to make a triangle. from this last segment that I made here, I'm going to turn this into a triangle, like so. And now what I'm going to do is copy this triangle onto the other side of the line. But I want to reverse it. So I want to take this segment and put it here, and I want to put this segment coming that way. So I'm going to take my compass and measure that segment, like so. I'll do that in blue. And I'm going to move my compass over here, because I want that segment to come from here and make an arc. So I've just measured this right here and moved it over here. And now I'm going to measure that length, but I want to put it over here. So let me do it the other way just so it's easier to move my compass. So I'm going to measure that length, and I'm going to put it here. And now I'm going to connect those this way to copy that triangle. Let me get that lined up a little better. Copy that triangle onto the other side of the line. So what I've done there is constructed a parallelogram. And this triangle is this one reversed. Now I'm going to take my compass and measure these marks that I made on the first side here. And I'm going to put them on this line. There's one. There's two. And if I do my construction correctly, that should line up perfectly there. And now I just connect the green lines on either side. And because these are the same distance apart, these are all congruent. So I've divided the line into 3 equal pieces. I could do 5, I could do 7, I could do as many as I wanted, just by making the number of marks on that line. All right, and I think what I'll do at the beginning of the class on block day for us would be Wednesday. I'll do that construction again, just so we can refresh it. This would be dividing our segment into equal segments. Now, divide even segments, we can divide it in half and half again, or if I wanted to do this construction for 4 segments or 6 segments, I can do that. I can still do this construction. All right, so that's the only new one that we need for our project that we haven't learned. Okay. We turned our homework in. Well, Friday we had a quiz. We turned our homework in class last week on block day. So there's nothing to put in the folders. So our homework is page 800. A through 18 even. 20, 24. 26 through 38 even. 44, 45, and 52. I will give you some review problems to look at on block day, review for our test. The chapter 12 portion of your final review packet, those questions are very good review for the chapter 12 test. So all the stuff at the end of your final review packet about circles, those would be good problems to do before the test. Okay.